Physical Science Part A Module I, Renaissance and Freedom Movement Module 2, General Knowledge and Current Affairs Module 3, Methodology of Teaching the Subject History Conceptual Development. Need and Significance, Meaning Nature, and Scope of the Subject. Correlation with other subjects and life situations. Aims, Objectives, and Values of Teaching, Taxonomy of Educational Objectives, Old and Revised Pedagogic Analysis Need, Significance and Principles. Planning of Instruction at Secondary Level Need and Importance. Psychological Basis of Teaching the Subject, Implications of Piaget, Brunner, Gagne, Vygotsky, Ausubel and Gardiner, Individual Difference. Motivation, Maxims of Teaching. Methods and strategies of teaching the subject, models of teaching, techniques of individualizing instruction. Curriculum, definition, principles, modern trends and organizational approaches, curriculum reforms, NCF, KCF. Instructional resources, laboratory, library, club, museum, visual and audio-visual aids, community-based resources, e-resources, textbook, workbook and handbook. Assessment, evaluation concepts, purpose, types, principles, modern techniques, CCE and grading tools and techniques, qualities of a good test, types of test items, evaluation of projects. Seminars and assignments, achievement test, diagnostic test, construction, characteristics, interpretation and remediation. Teacher, qualities and competencies, different roles, personal qualities, essential teaching skills, microteaching, action research. Part B Module I Particle Dynamics, Newton's Laws of Motion, Rotational Dynamics, Conservation Laws, Linear Momentum, Angular Momentum, Energy. Simple harmonic motion, damped and forced. Oscillations, wave motion, progressive waves, superposition of waves, Doppler effect. Frames of reference, special theory of relativity, elasticity, Young's modulus, rigidity modulus, bulk modulus, surface tension, viscosity. Module 2 Electrostatics, transient current, current electricity, electromagnetic induction, alternating current, magnetic properties of materials. Semiconductor physics, diodes, transistors, amplifiers, oscillators, logic gates. Module 3 Reflection, refraction, dispersion, interference, diffraction, scattering, polarization, fiber optics, lasers, basic idea of spectroscopy. Heat and thermodynamics, conduction, convection, radiation, laws of thermodynamics. Carnot engine, entropy. Statistical distribution ensemble, phase space, Maxwell-Boltzmann statistics. Module IV Bohr atom model, vector atom model, hydrogen spectra, nuclear structure and properties. Radioactivity, nuclear fission and fusion, elementary particles. Crystal structure, crystal symmetry, Miller indices, Bravais lattice, Bragg's law, packing fraction, superconductivity. Wave nature of matter, uncertainty principle, postulates of wave mechanics, Schrödinger equation. Module V Eigenfunctions and Eigenvalues, postulates of quantum mechanics, time Schrödinger wave equation, application to particle in a one-dimensional box, normalization of wave functions, application of Schrödinger wave equation to hydrogen atom, conversion of Cartesian coordinates to polar coordinates, radial and angular functions, mention only, orbitals and concept of quantum numbers, energy levels in molecules, Born-Oppenheimer approximation. Rotational, vibrational, Raman, electronic and NMR spectroscopy, basic principles and applications. Elements of symmetry of molecules, amorphous and crystalline solids, defects in crystals, stoichiometric and non-stoichiometric defects. Ideal and non-ideal solutions, Henry's law, Raoult's law, dilute solutions, colligative properties, abnormal molecular mass, Van't Hoff factor. Solubility product and common ion effect, precipitation of cations, principles of volumetric analysis, theories of indicators. Principles and applications of column chromatography, paper chromatography, thin layer chromatography, ion exchange chromatography, RF values. Structure and applications of silicones, silicates and zeolites. Cement, glass, inorganic. Fertilizers, rocket propellants, brief study, types of pollution, air and water. Pollutants, control of air and water pollution. Module V Atom models, Planck's quantum theory, photoelectric effect, de Broglie's relation, dual nature of matter and radiation, Heisenberg's uncertainty principle. Atomic orbitals and quantum numbers, Pauling's exclusion principle, Hund's rule of maximum multiplicity, Aufbau's principle, electronic configuration of atoms. Ionic bond, properties, Born-Land equation, derivation not expected, Born-Haber cycle, Fajon's rules and its applications. Covalent bond, valence bond theory vs EPR theory, concept of hybridization, types, sp, sp2, sp3, dsp2, sp3d, d2sp3, sp3d2 explanation with simple examples, molecular orbital theory, LCAO, bonding and antibonding molecular orbitals, bond order, theories of metallic bonding, free electron theory, valence bond theory and band theory, basics concepts only, hydrogen bond, intra and intermolecular. Hydrogen bond, periodic laws, periodic properties, electronegativity scales, Pauling and Mulliken scales, effective nuclear charge, Slater rule, diagonal relationship, representative and transition elements, general characteristics, preparation and properties of simple compounds, lanthanides and actinides, metals, occurrence, concentration of ores, refining of metals, extractive metallurgy of Al, Fe, Ni, Ku and T, classification of steel, hardening of steel, isomerism and coordination compounds, Werner's theory, Ian rule, valence bond theory, crystal field theory, splitting of d orbitals in octahedral, tetrahedral and square planar complexes, applications, organometallic compounds, definition, classification and applications, radioactivity, natural and artificial, nuclear stability, NP ratio, nuclear forces, half-life period, Geiger-Nuttall rule, disintegration series, transmutation, nuclear fission and nuclear fusion, application of radioactive isotopes, Module 7, postulates of kinetic theory of gases, collision number, first law of thermodynamics, Joule-Thomson effect, liquefaction of gases, inversion, temperature, second law of thermodynamics, concept of entropy, entropy is criteria of spontaneity, free energy functions, Hess's law, bond energies, third law of thermodynamics, law of mass action, law of chemical equilibrium, equilibrium constant in terms of concentration, partial pressure and mole fractions, Van 't Hoff's equation, homogeneous and heterogeneous equilibria, Le Chatelier principle and its applications, rate of a reaction, factors influencing the rate of a reaction, rate law, order and molecularity, rate constants for first, second, third and zero-order reactions, half-life period for first-order reaction, Arrhenius equation, collision theory, transition state theory, homogeneous and heterogeneous catalysis, enzyme catalysis, photosynthesis, simple photochemical reactions, fluorescence, phosphorescence, chemisorption and physisorption, factors affecting adsorption, adsorption, isotherms, classification, preparation, purification and properties of colloids, protective colloids, gold number, applications of colloids, phase equilibria, components and degrees of freedom, one component and two component systems, simple cases only, Faraday's laws, Kohlrausch's law, Arrhenius theory, Ostwald's dilution law, Debye, Huckel, Onsager's equations for strong electrolytes, galvanic cells, electrochemical series, Nernst equation, Module 8, uniqueness of carbon, classification of organic compounds, hybridization of carbon in organic compounds, structural and sterisomerism, Bayer strain theory, conformation and configuration, specific rotation, chirality, enantiomers, diastereomers, racemic mixture, resolution methods, inductive effect, mesomeric effect, hyperconjugation and electromeric effect, steric effect, organic reactions, substitution, addition, elimination and rearrangement, mechanisms of SN1, S2,